NASA may be withholding critical information about a mysterious interstellar object passing through our solar system.
The news struck like a thunderclap across the scientific community when the NASA stepped forward and acknowledged that they had built something far beyond our wildest expectations. A device so advanced, so unprecedented that it could conceivably approach the cosmic speed limit of light. The implications are staggering, the promise intoxicating, and the possibilities almost beyond human imagination. As the door to what was once purely science fiction swings open, our perception of space, time, and humanity's place in the universe may be about to shift irrevocably. Before we start, smash the like and subscribe buttons for more updates. From the start, the engineering team involved made clear that the breakthrough is neither trivial nor incremental. This isn't simply a faster rocket or a slightly improved propulsion system. This is a leap into a domain previously reserved for theoretical physics and speculative fiction. The device taps into regimes of relativistic motion, a realm where distances collapse, time dilates, and the familiar rules begin bending. For decades, we've considered near light speed travel a distant dream, something relegated to decades, centuries, or even millennia of future effort. Now, NASA is effectively saying that the architecture is in place, the concept tested, and the engine of possibility ignited. What does approach light speed really mean in this context? To journey at even 90% of the speed of light would render interstellar distances manageable in lifetimes rather than eons. Imagine a craft leaving Earth and reaching the outer edge of our solar system in a fraction of the time it currently takes. Imagine neighboring stars no longer as glimmers in the sky, but as destinations within reach. With such speed, the universe's landscape changes. Star systems become accessible. New planets become bodies we could visit, explore, or even inhabit. But with the promise comes profound complexity. Traveling near the speed of light is not simply a matter of accelerating harder. At relativistic speeds, mass increases, time slows relative to external observers, and energy requirements soar exponentially. NASA's announcement reflects that this technology confronts those very challenges head-on. They have developed a system capable of generating thrust in regimes where classical mechanics give way to relativistic mechanics. The vessel must cope with the intense demands of energy, shielding, and the inherent risks of moving so fast through a diffuse but ever-present cosmic medium. Collisions at such speeds could be catastrophic. Even a speck of dust becomes a formidable threat when you're hurtling through space at nearly the speed of light. The engineering behind this breakthrough reportedly utilizes novel concepts of propulsion, energy conversion, and perhaps even interactions with fields or space-time geometry in ways previously untested. Gravity, electromagnetic fields, quantum effects, all may be coming into play. NASA hints that the system moves beyond chemical rockets, beyond nuclear drives, into a paradigm where acceleration, inertia, energy, and momentum become things to manage in entirely new ways. The very nature of acceleration shifts, from pushing against propellant to leveraging interactions that alter momentum with minimal mass ejection. This marks a radical change in how we conceive of travel in the vacuum of space. The ramifications for space exploration are enormous. With a craft capable of near light speed travel, mission times to Mars, the asteroid belt, the outer planets, and beyond shrink dramatically. The entire architecture of human presence in the solar system could transition from slow voyage to rapid deployment. Colonization, logistics, supply chains, research networks, all could evolve from decades-long planning to months or even weeks. For unmanned probes, reaching distant systems becomes not a matter of future generations, but of imminent possibility. For human missions, the dream of reaching the stars no longer stays tethered to centuries or generational ships. The stars may move from being unreachable blurs to reachable milestones. Beyond exploration, the scientific consequences are profound. High-speed travel opens opportunities to test physical laws in extreme regimes. Time dilation alone becomes accessible, meaning experiments in chronometry, causality, and perhaps even the structure of space-time itself. Observatories moving at relativistic speeds could inspect cosmic phenomena from unique vantage points, sending data back to Earth in unprecedented ways. The universe's structure could be probed with probes moving at a significant fraction of light speed, bringing back observations as though we were looking at it in fast-forward or high resolution. We might witness stellar life cycles in condensed form or map cosmic phenomena in ways previously impossible. There are also perhaps philosophical and societal implications. Humanity might begin to think of itself as not just a planet-bound species, but a star-faring one. The horizon of human experience extends beyond our solar cradle to the galactic neighborhood, perhaps even beyond. If we make such speed a reality, the notion of barrier between stars blurs. Cultural, political, and economic systems would change when travel becomes faster than light years rather than decades. The new frontier becomes reachable, and reachable means actionable. Plans for interstellar research stations, outposts on distant bodies, even the first contact with other life forms shift from contemplation to actual blueprinting. The technologies developed by NASA for this milestone likely spill into myriad other domains. Power generation systems, capable of handling the enormous energy fluxes demanded by relativistic travel, could revolutionize terrestrial energy systems. Materials engineered to withstand high-velocity impacts and extraordinary stresses may lead to safer, more resilient infrastructure on Earth. Navigation systems based on relativistic frameworks might improve our understanding of time and space, enriching everything from GPS to computational modeling of complex systems. The ripple effects of achieving near light speed capability will extend far beyond rockets coastward. One of the most intriguing aspects is what this means for the concept of time itself. As a vessel approaches the speed of light, time aboard the craft slows relative to an outside observer. For the crew, decades might pass while centuries or more pass back home. In a sense, the traveler steps into a different temporal frame. This opens possibilities and paradoxes: long-distance travel where one returns to find everything changed, or missions where time dilation becomes strategy. The way we think about lifespan, generational investment, mission duration, and even human aging might be reframed. The future becomes pliable. The stars become pivot points in human chronology. There are, of course, massive hurdles. The energy demands are staggering. Even if NASA has solved the propulsion concept, building a system of this magnitude and safety is a monumental task. Radiation from interstellar space, micrometeoroid impacts, navigation at relativistic speeds, communication delays, and maintenance of human health in extended high-velocity voyages all remain significant. The paradox of speed is that as you go faster, you cross more space, but you also face more risk, more isolation, more complexity. The ship becomes not just a vehicle, but a micro-world carrying life, systems, and tasks at velocities approaching the cosmic law. Still, the mindset has shifted. Instead of asking whether we could reach the stars someday, we now ask when and how. NASA's admission marks a pivot point. For decades, the limiting factor in interstellar travel has been propulsion, energy, materials. Now one major hurdle appears surmountable. Once that hurdle is overcome, others stand in line to be met. Sustainable life support systems, human physiological resilience, long-range communications, and mission architecture. But the first domino has fallen. The human race could be entering a chapter where crossing interstellar distances enters the realm of engineering rather than pure speculation. The global implications are significant as well. The geopolitical landscape of space may transform. Nations that master near light speed travel gain strategic advantage, not just technologically, but in how they can deploy resources, research outposts, and even defend assets across solar systems. International cooperation will likely become even more crucial. The ethical, legal, and governance frameworks for such travel, once about Earth to Mars missions, will now stretch across interplanetary and eventually interstellar domains. Who controls what? Who travels where? What obligations do we carry when visiting other worlds or systems? These questions extend into whole new frontiers. In the world of commerce and industry, the doors open wide. Space mining, interstellar logistics, and new scientific enterprises become conceivable rather than fantasy. Access to the far reaches of the solar system and beyond could lead to resources unimaginable from Earth's perspective. The concept of distance cost plummets. Economies may evolve in ways we've only begun to dream. Supply chains stretching across stars, commodity flows from distant asteroids, manufacturing in deep space. The business of space takes on a new magnitude. Symbolically, this moment stands as a testament to human ambition and capacity. For generations, humans have gazed upward, longing to cross the thresholds defined by light years. To have an organization like NASA announce that they've built something capable of nearing those speeds is to reaffirm that the human spirit of exploration remains alive and potent. It signifies that the boundaries of what we once considered insurmountable are still shifting. We are not locked into the limitations of past eras. We continue to innovate, push, create. This device, more than the sum of its parts, represents a cultural milestone. The moment when the stars stop being just inspiration and begin being direction. Of course, one must keep perspective. Building a system that can reach near light speed is not the same as doing it tomorrow, and many steps still lie ahead. But the transition from maybe in our children's lifetimes to within planning horizons is profound. Humanity has always measured time in centuries and millennia for interstellar travel. Now that unit may shrink to decades, perhaps a generation. The psychological effect of that shift cannot be overstated. Where once the universe felt vast and unreachable, the universe now feels reachable and meaningful. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA creating tech that might reach light speed? What do you expect? We want to hear from you. Thank you for watching and see you next time.